Okay, just a quick recap. So this unit, are talking about congruent triangles. So the first couple sections, we talked about proving triangles are congruent by knowing there are 6 congruent parts, 3 sides, and then 3 angles. And that was the only way that we knew how to prove triangles congruent. Once we knew 3 sides were congruent to 3 sides on another triangle and 3 angles were congruent to 3 angles on another triangle, then we knew that 2 triangles were congruent. Then we learned our first shortcut, which was SSS, or side, 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 which stated that if I know that these 3 sides of a triangle are congruent to these 3 sides of the triangle, then I can say that the 2 triangles are congruent, okay? So today we are going to talk about 2 additional shortcuts. So we know side, side, sides 1, SAS and HL are the 2 next ones that we are going to prove congruent. Okay, so SAS is side, angle, side. So if 2 sides of a triangle with the included angle, what that means is, excuse me, this side, they create this angle R. So if the 2 sides that create the angle are congruent to the 2 sides that create the angle on 2 different triangles, that means that these 2 triangles are then congruent, okay? It would not work if it was angle S and V and not R and U. So if I knew that those 2 angles and then these 2 sides were congruent, that would not mean that those 2 triangles are congruent. That would not work. It has to be the included angle, okay? The second shortcut for today, or third shortcut total, is HL. HL stands for hypotenuse leg. So when we talk about having a hypotenuse, this has to be on a right triangle, because right triangles are the triangles that have a hypotenuse. So on a hypotenuse leg, congruence theorem, what this is saying, I have to have a 90-degree angle, so I have to have a right triangle. As long as I know the hypotenuse is congruent to the hypotenuse, and then either one of the 2 legs, it doesn't matter which one, because the other 2 sides are both called legs, then one of those legs has to be congruent to the leg on another triangle. That means that those 2 triangles are then congruent, okay? Use the diagram to name the indicated angle between the given pair. So you're finding included angles is essentially what you're doing here, okay? AB, so this side, with BC. So we're trying to figure out what angle those 2 sides make. Well, that makes this angle right here. Remember, sometimes you can name an angle with 1 letter, but other times you have to name it with 3. This is the time that you would have to name this angle with 3 letters, because there is actually 1, 2, and then the big third angle at that angle. So if I just named it with 1 letter, I wouldn't know which angle of those 3 angles you're talking about. This angle can be called angle A to B to C, or angle C to B to A. Either one of those. Next, side length BC and side length CD, they create this angle right here. That can be named with 1 letter, angle C, or you can name it with 3 letters, which would be B to C to D, or the backwards of that, D to C to B. Remember, I can go this way or I can go this way, same angle. Next one, actually go ahead and pause me. Try to figure out 3 through 6 on your own. Unpause me when you are done. A to B and B to D. So that would make this angle, which is angle A to B to D, or we call it D to B to A. Next one is B to D and D to A. That would be angle A to D to B, or angle B to D to A. Next would be DA and AB. Well, that's just that one angle A. There's no other angle at that one, so I can call it with 1 letter. You can also call it DAB or BAD. And then the last one is C to D and D to B. So that one has to have 3 letters, so that would be angle C to D to B, or angle B to D to C. Next, decide whether there's enough information to state if the triangles are congruent. If there is enough information, which congruence theorem or postulate? So remember, we have 3 now. We have side, side, side. We have side, angle, side. And we have hypotenuse leg. So it would have to be one of those. So on this one, I see an angle here with an angle here, this side with this side. I also know that these two sides, or this side, is congruent to itself by reflexive. So what I have here is angle, side, side. Remember, for it to be side, angle, side, where I have two sides and an angle, yes, I have two sides and an angle, but that angle has to be in between the two sides. So it would actually have to be this angle and this angle because they're in between the two sides. That is not the angle that they gave us, so this one is no, not enough information. NEI, not enough information. Next one, I have this angle with this, or sorry, this side with this side, I have this angle with this angle, and then this side with this side. This angle is the included angle in between the two sides. So this one would be yes. This is by side, angle, side. Next one, I know this is a 90-degree angle, so it's a right triangle. I know that this leg is congruent to itself. We don't know any other side, we don't know any other angles, and we don't know the hypotenuse for sure. So this would be no, not enough information. What I do have is I have a side, and I know that if that's 90, this is also 90, so I have a side and an angle. But two things does not work. I would need three things, and they would have to be in the correct order. Next, I have a side here. I have this side that is on top of itself, and then I also know this is a 90-degree angle. Now, this would not be side, angle, side because the angle does not come in between the two sides. However, if you look at the two sides, this is a right triangle, and this is a hypotenuse. So I know a hypotenuse and a leg on a right triangle, so this is a yes by hypotenuse leg. All right. Next one. State the third congruence that must be given to prove that these two triangles are congruent. So I know that JR is congruent to DF, so I'm taking what they're giving me and I am just drawing it or marking it. I know JM is congruent to DB. They want me to prove that those two triangles are congruent by side, side, side. So I have two sides. I would need to have the third side. I would need to know that this guy is congruent to this guy. So that's the third thing I would need. I would need to know that RM is congruent to FB in order to prove it by side, side, side. Pause me and try to do 12 and 13 on your own. Unpause me when you're done. Next one, I know JR is congruent to DF. I know JM is congruent to DB. We need side, angle, side to prove this one. So in order to do side, angle, side, I would have to have an angle in between my two sides. So that would make this angle with this angle. So angle J would have to be congruent to angle D. You could write that as one letter or three letters here because there's only one angle there. Three letters would be RJM or MJR with FDB or BDF. 13, I know that R to M is congruent to F to B. I know angle J has a right angle, and I know that J and D are congruent. That would make that a right angle. So they want me to prove by hypotenuse leg. Well, I have a hypotenuse. The other thing that I would need would be a leg. So it could be JM with DB in the correct order, or I could do JR congruent to DF, and that's an or. Just one of those two legs congruent. I don't need both of them. Okay? Number 14, given B is the midpoint of A to E and B is the midpoint of C to D, prove that these two triangles are congruent. B is the midpoint. That means that that is a given. What do I know because of definition of midpoint? Well, and they're going off of A to E. Well, that tells me that A to B is congruent to B to E. So this is congruent to E. That. Next, they are telling me that B is the midpoint of C to D. That again is a given. They told us that up top. Which tells me what because of definition of midpoint? Well, that tells me that B to D is congruent to B to C. All right. Then angle A to B to D, this angle, is congruent to E to B to C, this angle. Those are across from one another. Remember, those are definition of vertical angles. And I actually think that that's called vertical angles congruence theorem is how you'll see it in Schoology. Therefore, this triangle is congruent to this triangle by, well, I have a side here, I have an included angle, another side here. So that would be side, angle, side. Go ahead and pause me, and I want you to try 15 on your own. Unpause me when you are done. A to B is parallel to C to D. They did the marking of the arrow. A to B is congruent to C to D. They did that marking. So this is given because they are parallel. A to B to C, this angle is congruent to D to C to B, this angle. Well, those are parallel lines, transversal, so that would be alternate interior angles theorem. A to B is congruent to C to D. That was a given. This is congruent to itself. That's reflexive. POC. It's C because they are congruent. It is congruent. Now, this triangle, they're saying this triangle right here is congruent to this triangle by, well, I have a side here, I have an angle here, and then I have another side. So that would be side, angle, side. Okay, so what you have now is you guys just have one Schoology assignment to go with 4.4. So go ahead and make sure you have those notes taken and go ahead and complete that 4.4 homework assignment.